Alright, now here we are on our very last video of the course. It's rather exciting. I hope it will be alright. So we have, I think, 3 examples to get through. It has to do, again, we're going to be working with this formula right here that tells us the term of a binomial expansion. And these are some variations that, some of the more complicated examples that you see sometimes. Here's one. It says, find the term that contains x to the fourth when simplified of the binomial expansion of this x squared minus 2 over x to the 11th power. Okay, well, if we were to expand this out, okay, so the first thing is we would get like 12 terms, right? 12 different terms. The first one would have this one to the 11th power, so we'd have some number x to the 22, right? And this number would come down and that number would go up, so then we would have another, x over that, and so on. At some point, we're going to have some term that is going to have x to the fourth. So when we combine the effect of this x squared and this x in the denominator, that we get an x to the fourth. I wonder which term that is. So that's what we're going to have to figure out. Okay, so in that formula, you recall that the term is the subscript, is the k plus 1. So we're looking for what is k plus 1. So k plus 1 is equal to the term number. So what we're going to have to be careful of is when we're all done at the end, we're going to say, say k is 3, then k plus 1 is equal to the term number, and we would say it is the fourth term. Okay, so just make sure that once we got k done, that we add 1 to it to get what term number it is. Okay, so let's clean up my mess here. We know that this term will have x to the fourth as a variable. So we're going to bring out our formula here. And the first thing that we're thinking of is that I don't care about what the coefficient is out front. All I care about is the x to the fourth. So in this formula part here, I don't care about this combination because that just contributes to the coefficient. Also, I know that a is equal to x squared, and I know that b is equal to negative 2 over x, but really the only part that I need is this 1 over x business. I don't care about the 2. Okay, so I'm going to simplify a. I'll keep it as x squared. B I'm just going to write as 1 over x. So you see that's what's been done here. Okay, now the last part is we are told that this is to the 11th power, so in other words that n is equal to 11. So the next part that we do here is I'm going to write x squared to the power of, instead of n, I'll write 11 minus k multiplied by 1 over x to the k. Alright, now where did this x to the fourth come from? Well, that's because they told us that, term number k plus 1 is equal to the x to the fourth. So that's the part that we know is x to the fourth. Alright, so we're almost home. X squared to the power of 11 minus k. So let's deal with this part here. This power to a power turns into x to the power. When it's a power to a power, you multiply. So this is going to be the same thing as to the power of 22 minus 2k. Multiplied by, now if this is 1 over x, so it's going to be the same thing as saying 1 over x to the k is equal to the x to the fourth. Okay, now what do we do when we've got 1x in the numerator and an x in the denominator? Like what happens if we had x to the fourth multiplied by 1 over x to the 3? That's be the same thing as saying x to the fourth over x to the 3, and we subtract that. Okay, so there's my example. So we're really subtracting this. So if I combine these two terms together, I will get x to the, try to make my x better, x to the 22 minus 3k. And that will be equal to x to the fourth. Now we're ready to say 4 is equal to 22 minus 3k. So once we got it to the x to the power of x to the power, then we can do that. Alright, so I'll add 3k to both sides and subtract 4 from both sides, and then I guess I divide by 3. I get k is equal to 6. So what's the term? Okay, so term k plus 6, right? So this is the 7th term. Cha-ching, got that done. All right, so remember that last part about that this tells me term k plus 1, so that's why it's the 7th term. Okay, so there is another way we could do this, okay? Another strategy to find the value of k is to find the pattern formed by the variable. Okay, so if we were to think about what's the first term, right? So again, our formula here is, I'll make it t of k plus 1 is equal to, and then we have this nc k, and then we have a to the power of n minus k and b to the power of k. Now again, we don't have to worry about this part because it's just a coefficient, but if we were to think about what's the first term, so the first term is when you have your a value to the 11th, right, and your b value to the 0. Your second term is when a is to the 10th and b is to the 1st, and then a to the 9th and b squared. Remember how that this one descends and this one ascends, goes up by 1 each time. Alright, well, a is actually x squared, so this will be x squared to the 11th multiplied by 1, so this is going to be x to the 22. In my second term, a is x squared, and that is to the 10th. And then that's multiplied by b to the power of 1. So now, again, the only part about b I really need is the x, and it's in the denominator. So it's going to be equal to 1 over x. So what does that give me? X to the 20th minus 1. So it's going to be x to the 19th. So the reason why we're doing this is to find the pattern. So all I'm looking at is the x part. So I noticed that this went down by 3. I'm going to do another one to make sure that that is the pattern. So now I go x squared to the 9th multiplied by 1 over x squared. So I get x to the 2 times 9 is 18. 18 minus 2 is 16. So again, I get a drop of 3. Okay, so now I'm wondering if I just kept on extending this pattern, at what point would I get x to the 4th, right? That was the question. It says, when is it x to the 4th? Well, let me see here. My 4th term, if I went down by 3 again, would give me an x to the 13th. And then I'm thinking x to the 10th, x to the 7th, ta-da, x to the 4th. So this would be term 5, term 6, term 7. So I would say the 7th term. Okay, so you see how this one is more about looking for a pattern and continuing the pattern. The previous way was much more algebraic in its nature. Both are perfectly acceptable. Example number 2. 2 out of 3, so we're getting pretty close here. Determine the constant in the binomial expansion of this. So again, you're going to start off like your first term is going to be some number, and it's going to be what, this one to the 18th and this one to the 0. So the first term will be something p to the 18th, right? And that is going to get less and less and less. At some point, t to the k plus 1, it's going to be p to the 0. In other words, it'll be an expression without any p in it at all. So we're going to again say, okay, if t to the power of k plus 1 is equal to, I'll write this nck, even though we're not going to be using it, times a to the power of n minus k and b to the power of k, we're wondering at what point are we going to get a p of 0. So we want to know this term here is going to be p to the power of 0. I'm not worried about this part. And for my a, even though a is equal to 3p, I only need the p part. So I'm going to say p to the power of n minus k. So I know that n is equal to 18. So I'm going to say 18 minus k multiplied by, now again, the only part about b I need is the fact that it's got a p in the denominator, and that is to the power of k. So I will say here that 0 well, here I'll write one more statement here. I'll put this together is equal to p to the power of 18 minus k, and then what happens here? The p is in the denominator, so I'll be subtracting another k. So here I'll write it out without the p part now. 0 is equal to 18 minus 2k. So 2k is equal to 18. So k is equal to 9. And so remember that. What term then? So that would be term k plus 1. So it's my 10th term. All right, so that was using that first method. If you wanted to, maybe method number 1. If you wanted to say, hey, how would you do method number 2? Sure, I'll show you how to do method number 2. Maybe we should switch to blue for that one. So in method number 2, we'd say, okay, the first term would be this p to the 18th. Oh, maybe I'll just show the step in between. It'd be a to the 18th, b to the 0. T2 would be a to the 17th, b to the 1. Term 3 is a to the 16th, b squared. Okay, so my first one, a to the 18th, just only looking at the p part, that would be p to the 18th. And then since b to the 0 is 1, I don't need to worry about it. A to the 17th, so that's p to the 17th, multiplied by 1 over p to the 1, so I get p to the 16th. So it looks to me like I'm getting a drop of -2 each time. Let's just see if that continues. Let's do one more to make sure. So here I'll have p to the 16th multiplied by 1 over p squared is equal to p to the 14th. So yeah, it seems to continue. And we want to know when will it be equal to p to the 0. Okay, so it'll be t to the 4th is going to give us p to the 12th, 10, 8, 6, 4, 2, 0. So that would be 5, 6, 7, 8, 9, 10. Okay, so at t to the 10th, then we're going to get a p to the 0. So we'll say the 10th term. Okay, so those are our two methods. Here we are for our very last example, example number 3. So it's a little bit of a variation on this one. Determine the value of n. So now we've got to figure out what this power, the n power is, before we expand it, if the 5th term of the expansion is that. Okay, so again, we'll take this t to the power of k plus 1 is equal to nck of a to the power of n minus k and b to the power of k. And we can simplify this and just say, hey, just the x squared part, that's enough. Okay, so just like before we simplified things, I can say, don't even worry about this. And even though a is equal to 2x squared, I'm just going to use x squared. And even though b is negative 1 over x, I'll just use 1 over x. Okay, so moving on here, I'll say, and if it's the 5th term, that's another good point to remember here. So the t to the 5, so in other words, k plus 1 is equal to 5, k is equal to 4. Okay, so remember you make that adjustment here. So this is going to be equal to, so my x, this will have an x squared in it. So rewriting this but not worrying about the coefficient, x squared is going to be equal to my a value, which is x squared, to the power of n minus k, so it's n minus 4, multiplied by my b value, which is 1 over x, multiplied to the power of 4. So I'll get x squared is equal to x to the power, this will be 2n minus 8, and then this will contribute another minus 4. So I can say 2 is equal to 2n minus 12. So if I add 12 to both sides, I get 14 is equal to n, so n is equal to 7. There we go, and we got an answer for that last one. I hope that that made sense for you. And here is your last set of homework. And yeah, look forward to seeing you in class. Bye.